In this section, we're going to introduce a framework for implementing sorting algorithms in Java. Up until now, we've just talked about the vague concept of sorting as well as what it means mathematically. Now, though, right in order to implement algorithms, we need to start looking at code. So the first thing we have here is this little framework. So this is sample code. You can grab it off of your favorite learning management system. I want to say Blackboard, but I know we're changing to Canvas, so we'll just say your favorite learning management system. This is some basic code that we're going to be using again and again to implement our different sorting algorithms. So this is just a class called sort. Here, right, this is kind of my to-do part here. This is my sorting algorithm, which I'll vary as I go through these different things. And then I have a bunch of helpers. So the first helper I have is this thing called less. So less, basically, I give it two elements, and it'll tell me, are they in the proper order now, right? Is this one less than this other one? So we're comparing V and W. And this ends up, basically being fed over to the comparable interface. So notice these two are basically, they're coming in as comparables, right? V and W are both comparable. And then we're calling, v.compare2 of W less than 0. Here, right, we're kind of simplifying our syntax a little bit. So rather than writing sorting algorithms, I have to always do that test for less than 0. We're basically just, farming it out to this method that says, okay, is this less than that? Right, that's all I need to know. So we'll use this all over the place. Yeah, so so it's called less. Notice that I will sometimes refer to this as a comparison. So these two actually, the one we're talking about right now and then the one we'll do in a second, are basically like the key operations. So these are like going to be the main things, or the main work that our sorting algorithm has to do. That also means that they're going to be the main things we analyze when we're doing some analysis of algorithm stuff. So we're going to count up the number of times less is called, the number of times exchange is called. All right, so moving there into exchange. So exchange is the next one. So in that case, we have basically a reference to an array. So this is, where is our data? Where is it coming from? That's basically some array called A. And then we have two indices, right? So I and J. The goal here, right, is basically just to flip the contents of them. I want to take out, one element from one position, put it in the other position. It does that using kind of typical code, right, which is to have a temporary variable you store something into, then you do one assignment and then do the other assignment back from the temp. So yeah, just looking at an array, change two things, right? Flip them in their where they're stored, what indices they're at. So this is the second thing we'll kind of use a lot in terms of our analysis. We'll be looking for how many exchanges. Typical exchanges are very complicated. Notice here we have to create a new variable. We have to do two assignments. It's not just well, we're doing a function calling the other one, but generally the exchange will be slower than less than. So yeah, those are two of our kind of key algorithm methods there. Next ones. These are more for us. So the next one is called show. Basically, it's just a little helper that loops over your array, goes element by element, and then prints it out. So you can see what's going on. Because you're going to have to write that a million times, so may as well put it in a function, right? When you have something you're going to write a million times, throw it in a function, make it a reusable component. Don't waste your time doing it again and again and again. So yeah, that's pretty straightforward. Next thing over here is sorted. So this is kind of for troubleshooting. So the idea here is basically to check some input array and see whether everything's in order, right? So does it match in terms of that definition we saw earlier? So earlier we saw a definition of what it meant for an array or a set of data to be sorted, right? It was like, oh, this position is best this other position. That's what this is implementing. And that's this check over here is less A of I minus 1. That's checking to see whether those two elements are in order. And that's kind of nice for us because we can maybe put that in as a check to say, okay, is this thing returning a sorted array or not? Because maybe we're implementing something, we want to debug it, we want to see is it working or not. This is a nice little function just to check to see, is it something that we can, is it something that did its job properly, right? Did it give us a sorted result? So that's nice for debugging. All right, so we'll call these debug. Okay, so these two I'd say are, okay, so these are debug. And then these two over here are our algorithm. And then this over here, last one I'm talking about is test. So all this last thing is, and this will vary a little bit, and this is probably what you change right, if you're messing with stuff. It's just the main to run the algorithm on some data and see what the result is. So here you can see we created an array called A, populated it with some stuff, and did sort on it. Notice one thing here. Sort is an in-place function, right? It doesn't return something. It sorts the array it gets as a parameter. Okay, remember that. Because this is a void over here, right? So there's no way for it to return stuff. It has to just change in place the thing that it got the reference to. All right. Then we have over here an assert, and then is sorted. So it's like, well, did you actually do your job or not? I remember that the assert command, right, it requires assertions to be enabled, but if they are enabled, what happens is it'll throw an exception, right, if that thing doesn't work, right? So if I run my program and isOr returns false and assertions are enabled, then it'll throw me an exception telling me right away that there is something wrong. So it's very nice for debugging because I press F5 to run the program and I know almost instantly, did it work or did it not work? Last thing, of course, is to show the result, right? So what is it that we got? So in this case, right, this will be moved around a little bit. I don't remember the exact output. I think E does go first. But yeah, it'll be alphabetized. So yeah, this is our little platform. We're going to be using this for all our different sorting algorithms. All right, so one thing I do want to talk about a little bit more here is kind of the notion of the comparable interface.